This module on Saturn engines has 4 sections with an overview of components emphasizing vibration control design, timing, including timing procedures and verification, major systems, and engine removal. Let's begin with an overview of the powertrain combinations. The Saturn Coupe SC and the Saturn sedans SL1 and SL2 use 2 versions of the 1.9-liter engine. The 1.9-liter L4 single overhead camshaft version with throttle body injection, or TBI, is available with the 5-speed manual transaxle, code MP2, or the 4-speed automatic, code MP6. The 1.9-liter L4 double overhead cam engine with multi-port fuel injection, or MFI, is available with the 5-speed manual, code MP3, or the 4-speed automatic, code MP7. Each of Saturn's 4 transaxles has specific gear ratios matched to its engine. Many Saturn engine parts, including the block, crank, and head, are made with the innovative lost foam casting process for lighter weight. Design and engineering also emphasize a systems approach to reducing vibration. Saturn engine powertrain support design helps control engine vibration with a 4-bolt transaxle to engine mounting, a 3-bolt mounting of the intermediate drive axle, a stiffener bracket between the engine block and transaxle converter housing, supporting mounts at the engine front cover and transaxle rear cover, and motion restricting mounts at the engine powertrain to cradle front, powertrain to cradle rear, and engine block to cradle on manual transaxle models only. The MFI engine has 2 additional vibration control features: this crankcase plate and support brackets for the intake manifold plenum and runners. The design of accessory support and drive components also helps control powertrain vibration in both Saturn engines. The water pump housing is integral with the block casting. The block also directly supports the generator and the cranking motor. 1 bracket on the TBI and 3 brackets on the MFI engine allow the block and cylinder head to support the power steering pump. And 2 brackets permit AC compressor mounting to the block and head. On both engines, the crankshaft pulley drives all the accessories with 1 Poly V design belt. Some of these TBI engine belt arrangements are not duplicated in the MFI's configurations due to different vehicle option content. An accessory drive belt tensioner mounts to the cylinder block. It provides constant tension from an internal spring. Now let's look at major component assemblies for Saturn engines. Both the TBI and MFI engines include a cylinder block assembly, a cylinder head assembly, a timing chain assembly, an intake manifold assembly, and an exhaust manifold assembly. The lubrication and cooling systems use parts from these groups, as well as other components. The cast aluminum cylinder block has 4 cast iron cylinder liners, which may be bored or honed during engine service. The liners are flush with the deck and are not replaceable. The TBI engine uses aluminum pistons that feature a domed contour that contributes to the 9.3:1 compression ratio in the TBI engine. 2 compression rings of differing design, a 3-piece oil control ring assembly, a cam-turned skirt design that on cylinder number 4 has a slight increase of bore clearance, and a free-floating connecting rod pin which uses retaining rings. In the MFI engine, the piston's face contour is different, allowing a 9.5:1 compression ratio. The crankshaft's 5 main bearings are a 2-piece tanged insert design. The center bearing has thrust flanges on its upper insert to control crankshaft end play. Alignment dowels guide iron caps for the crankshaft main bearings, and 2 bolts hold each cap to the block. The Saturn crankshaft is cast with the lost foam process and features 4 counterweights which are used for internal balancing. A slotted flange, which works as a reluctor ring. And a cylinder block-mounted crankshaft position sensor, or CPS, to provide signals for the distributorless ignition system. The crankshaft also features a flange for a rear seal, a key way to locate and drive a timing chain sprocket, which also rotates an oil pump drive gear in the front cover, and a threaded hole, which combines with the keyway to hold the pulley on the crankshaft. The connecting rod bolts, bearing inserts, cap, and nuts are of conventional design. Cylinder heads for the TBI and the MFI are very different, especially the combustion chamber layout. However, they have these features in common. Valve seat inserts, which can be replaced during service. Valve guide bushings, which are also replaceable. Valve stem seals, which double as spring seats. And valve spring caps, which use a two-piece retainer. To mount the head to the cylinder block, use the two alignment dowels. A head gasket, which is specific to the TBI or MFI engine, and 10 bolts, which are also unique to each engine and must be tightened with a torque angle procedure. The valve operation is also very different between the two engines. The TBI valve train hardware includes a single camshaft, which rotates in 5 machined bores in the cylinder head, a thrust plate for controlling end play, hydraulic roller lifters sliding in the cylinder head bores, prevented from turning by guides and retainers, rocker arms supported by needle-type roller bearings as they pivot on steel shafts, and valve springs, which are the same for both intake and exhaust. The MFI valve train has these features: valve springs, which are the same for both intake and exhaust, but different from the TBI engine. Hydraulic lifters, which transfer movement directly from the cam lobes to the valve stem tips. An intake and an exhaust camshaft, supported in bores formed by the cylinder head and bearing caps. And camshaft thrust flanges at the number 1 bearing, which work with the cylinder head to limit end play. Each engine has its own rocker or cam cover design with a specific RTV-based sealing gasket. Mounting components, which include seals, washers, and shoulder bolts. Baffles and a mounting hole for the PCV valve. Spark plugs for the two engines are different, and so are the secondary spark plug wire sets because of differing wire lengths and plug boot design. We'll discuss additional components in the sections on timing and systems. In this section on timing, we'll cover timing chain and tensioner components, proper cam timing, and timing verification procedures. The timing chains of both engines feature a crankshaft sprocket, which has flats to drive the oil pump, a single camshaft sprocket for the TBI engine, and a sprocket for each camshaft in the MFI engine. The sprockets are held in place by a dowel pin, bolt, and washer. The chain features a single-row roller design with silver alignment links for timing verification, a fixed chain guide with special shoulder bolts, and a pivoting chain guide with a pivot bolt and tensioner. The MFI engine also has an upper chain guide. 2 bolts mount the chain tensioner on the cylinder block at the front end of the main oil gallery. Engine oil pressure pushes the tensioner plunger, which keeps the pivoting chain guide against the chain. A ratchet device maintains chain tension during engine starting. During service, follow these procedures for TBI and MFI engine camshaft timing. Check that the crankshaft sprocket timing mark aligns with the split mark in the bearing cap to avoid valve damage. Position each camshaft so that its timing mark is in the 12 o'clock position. Now install a 3/16" drill bit or pin through each camshaft sprocket and into the cylinder head. Rotate the crankshaft 90 degrees counterclockwise only, so that its sprocket timing mark aligns with the cylinder block mark. Place the timing chain on the camshaft sprockets, aligning one silver link with the timing mark for the TBI engine. Align the two separated silver links with each timing mark for the MFI engine. Now for the TBI engine, align the remaining silver link, or for the MFI engine, the paired silver links, with the crankshaft sprocket tooth at the 6 o'clock position. Install the fixed chain guide. Install the pivoting chain guide. Now install the chain tensioner and unlock the plunger. And finally, remove the drill bit or pin from each camshaft. If there's no need to remove the engine front cover, here's how to verify camshaft timing after removing the rocker or cam cover only. Align the crankshaft pulley mark with the front cover mark. On a TBI engine, check that the letters FRT on the camshaft sprocket align with the cam cover to front cover sealing surface. On an MFI engine, the timing pin holes in the cam sprockets should align with the timing holes in the head. If the letters FRT or the timing pin holes do not align, rotate the crankshaft a full 360 degrees clockwise and check cam sprocket alignment again. In this section on major systems, we'll cover the manifolds and related components, cylinder block and head lubrication systems, including RTV sealant procedures, and the cooling system. Let's start with the manifolds. Both engines use threaded studs and nuts to mount intake and exhaust manifolds. However, each engine uses specific gaskets and has different passage configurations for intake air and fuel, coolant, and exhaust gas. The TBI engine has a throttle body assembly with a fuel injector and pressure regulator. Coolant passages inside the manifold help control the temperature of the intake charge and prevent throttle body icing. The MFI intake manifold uses an air-only throttle body. A coolant passage runs near the throttle plate area to prevent icing under certain conditions. A fuel rail with injectors and a pressure regulator mounts on the inner portion of the manifold. No cable adjustment is needed for the throttle body cable assembly. The TBI engine's EGR valve is on the intake manifold. The MFI engine's EGR valve is on the cylinder head itself. The positive crankcase ventilation or PCV valve vents crankcase vapors from the engine to the intake manifold. Vacuum ports on the throttle body route to the charcoal canister purge or CCP solenoid valve, an EGR solenoid valve. The manifold absolute pressure or MAP sensor on the TBI engine, and the fuel pressure regulator on the MFI engine. The TBI exhaust manifold is a cast iron design, and the MFI exhaust manifold is a tubular steel design. Saturn engines use a wet sump type oiling system and SAE 5W30 SG oil. The lubrication includes this stamped steel oil pan, a block-mounted dipstick and tube, a fill cap in the rocker or cam cover, a pickup screen and tube assembly, a front cover with integral oil pump and pressure regulator valve, pump suction and discharge passages in the cylinder block, an oil filter, cylinder block and crankshaft passages to lubricate crank journals and bearing surfaces, cylinder head passages with end plugs to lubricate valve train components, drain back passages in the cylinder head and block, and crankcase ventilation system baffles in the rocker or cam cover. Oil system sealing surfaces include the oil pan to block and front cover flanges, which require liquid RTV sealant. The front cover to block and cylinder head flanges requiring liquid RTV sealant. And the crankshaft rear seal carrier, which also requires RTV sealant. The rocker or cam cover to cylinder head and front cover flanges require pre-cured RTV sealant. Both the crankshaft front seal and this crankshaft rear seal are of a lip-type design. The MFI engine also has a crankcase baffle plate. It allows crankcase oil to avoid the rotating crankshaft. The extensive use of RTV sealant requires several service techniques. Use a drill bit to clean hardened sealant from all holes. Thoroughly degrease all sealing flanges using a chlorinated solvent. Remember, in all operations with aluminum engine parts, be very careful not to scratch or damage the sealing surfaces. Apply the correct amount of the RTV sealant that's specifically designated for Saturn engines, following the pattern shown in the service manual. After the parts have been joined, remove unhardened sealant from bolt holes. Use a light coat of oil on bolt threads and shoulder areas, and remember to follow the torque specifications in the service manual. Now let's track oil flow in the lubrication system. The TBI engine passages in the cylinder block and front cover are the same as those used in the MFI lubrication system. Passages for camshaft bearing and hydraulic lifter oiling in the TBI engine are very different than the MFI engine passages. The path of oil in each system begins at the sump. Oil flows through the pickup tube and into the oil pump. Notice the pickup tube and transfer port seals. From the oil pump, the oil flows into the cylinder block to the filter, or past the pressure regulator valve into pump suction again. Oil flows through the filter, which has a bypass valve to allow flow if the filter is plugged, and an anti-drain back valve to retain oil in lubrication passages when the engine is off. Oil then flows from the filter to the main oil gallery, where it travels to the timing chain tensioner, to each of the 5 crankshaft main bearings, then to the 4 connecting rod bearings, to a pressure gauge sending unit, and up to the cylinder head passages. Notice that the main oil gallery has threaded plugs in 3 locations. Oil flow in the cylinder head of the TBI engine lubricates the camshaft bearings and valve lifters. This restrictor in the engine block controls oil flow volume in the cylinder head at high speeds. Oil circulation in the MFI head is more complex to lubricate bearings for both the intake and exhaust cams and the valve lifters. The TBI and MFI cooling systems are similar, with some differences in hoses and hose routing. Drain plugs in the radiator and cylinder block allow system drainage during service. The thermostat is on the suction side of the system at the block end of the lower radiator hose. It is an integral part of the aluminum inlet housing, but the operating element of the thermostat can be replaced separately. The coolant temperature gauge sensor is mounted in the cylinder head and sends to the instrument panel. A coolant temperature sensor is mounted nearby and sends to the Powertrain control module. The PCM operates the electric cooling fan through a relay and also receives input from the AC system. The de-aeration hose for each engine allows air bubbles to be replaced by coolant. A block passage at the water pump also assists in removing air during coolant fill. The transparent coolant surge tank is pressurized and is made of a rigid polypropylene. Treat the threaded cap the same as a pressurized radiator cap. The engine coolant is a non-phosphate ethylene glycol base mixed 50-50 with water. It is used specifically for aluminum engine protection. No other chemicals should be added to the system. This section covers Saturn engine removal procedures and some critical points to remember during engine installation. The steps for removing or installing either a TBI or MFI engine are the same. After disconnecting the battery negative cable, remove the air induction tube, the air cleaner, and on the MFI engine, the air box. Cover the throttle body opening with a clean shop towel. Remove the air conditioning compressor. Use a wrench to rotate the belt tensioner in a clockwise direction and remove the accessory drive belt. Separate the AC clutch electrical connector. Now remove the 3 front and 3 rear compressor mounting bolts. Use wire to support the compressor from the frame. Drain the engine coolant by first removing the coolant surge tank cap. Remember, the coolant surge tank is pressurized. After placing a drain pan under the engine, remove the cylinder block drain bolt and washer. Open the radiator drain by twisting it counterclockwise. Remove the upper radiator hose and the heater core inlet hose at the engine. And remove the heater outlet hose and lower radiator hose. Also remove the de-aeration hose at the engine side. And secure the radiator to the frame support with wire. On ABS-equipped vehicles, separate both left and right front wheel speed sensor connectors. Now, refer to your service manual or removal checklist to make sure you disconnect all the components listed in the following areas. For an automatic transaxle, disconnect the oil cooler lines and plug the ends. And disconnect the turbine speed sensor, transaxle temperature sensor, valve body wiring, neutral safety switch, vehicle speed sensor, and shift cable. Secure the cable with wire. For a manual transaxle, disconnect the clutch hydraulic slave cylinder and clutch hydraulic damper, securing both with wire, the backup light switch, the vehicle speed sensor, and the shift cables, securing them with wire. For the engine, disconnect the ground wiring at the transaxle studs. Disconnect the wiring harness at the distributorless ignition system module, coolant temperature gauge sending unit, coolant temperature sensor, oxygen sensor, EGR solenoid, throttle position sensor, idle air control valve, map sensor, charcoal canister purge solenoid, PCM ground, throttle cable, which should be secured with wire, and disconnect the brake booster vacuum hose. Again, refer to the removal checklist or the service manual to avoid missing anything. Use tool SA9127E to bleed off the fuel system pressure. Use tool SA9157E to separate the fuel line fitting halves and disconnect the fuel lines. Now remove both front wheels and raise the vehicle. Remove the left and right splash shields using screwdrivers to lift the fastener heads. Remove the front brake caliper mounting bolts. Separate the calipers from the rotors and secure them to the strut springs with wires. Remove the bolts and nuts and separate the front struts from the steering knuckles. Separate the front exhaust pipe from the exhaust manifold. Remove the catalytic converter to front exhaust pipe bolts. Loosen the pipe bracket and lower the pipe. Remove the engine to transaxle stiffening bracket. Next, remove the flywheel dust cover and then remove the 4 torque converter to flex plate bolts. Again, check the service manual or your removal checklist to make sure you disconnect the generator shield and wiring, the cranking motor shield and wiring, the oil pressure sensor, knock sensor, crankshaft position sensor, electronic variable orifice steering actuator, and the power steering pressure switch. Now use a 12-point socket to remove the steering gear bolt. Separate the steering gear at the shaft, sliding the shaft away from the gear. Unclip the brake line from the rear side of the cradle. Now, lower the vehicle and lay the engine compartment electrical harness on the battery shield and the fuse and relay cover. After raising the vehicle again, position a powertrain dolly under the cradle using 2 4x4 by 36-inch blocks of wood between the cradle and dolly. Support the cradle with the dolly and remove the 4 cradle-to-frame mounting bolts. Then lower the powertrain from the vehicle. Remember to secure the cradle washers with wire. At this point, you can separate the engine from the transaxle. Remove the spark plug wire assembly from the ignition coils. Remove the power steering pump and bracket assembly and secure it to the cradle assembly with wire. Attach the adapter tool SA9105E and support the engine with a hoist. Remove the engine front mount, and if it's a manual transaxle, also remove the motion restrictor. Remove the studs and the cranking motor bracket bolt. Support the intermediate drive axle with a 1/2 by 1 by 3-inch wooden block. Remove the 4 transaxle to engine bolts and separate the intermediate drive axle bracket from the engine block. Lift the engine slightly with the hoist and pull it 4 inches away from the transaxle. Remove the clutch pressure plate and disc. And you can mount the engine on a stand using special bolts and spacers to protect the alignment bushings. You are ready to proceed with further repairs. Saturn engine installation is basically the reverse of the removal procedure. However, there are a few important things to remember. When working with a manual transaxle, install the clutch disc alignment tool, SA9145T. Start the pressure plate bolts by hand and torque the bolts to specification using a crisscross pattern. Throughout the installation procedure, consult the Saturn service manual for required torque specifications. This is important for vibration control and also because many components are aluminum. Consult the manual or the removal checklist to make sure you reconnect all engine, transaxle, accessory, and electrical system components, including all the various sensors, switches, and solenoids. Also remember to add engine oil, if necessary, and engine coolant. Then start the engine and check for fluid leaks. After running the engine for several minutes, you may have to refill the coolant surge tank to the full cold mark. Then listen to the sound of a job well done.